In previous segments, I described how you can incrementally refactor your monolithic application into a set of microservices. And I described various strategies that you can use to do that. And I also talked about how you must create an anti-corruption layer or glue code to integrate each service in with the monolith, because more often than not, they need to share databases. So in this segment, I'm going to describe a simple example that illustrates one way of adding new functionality onto a monolithic application as a standalone service. So the example I'm going to use is Spring Pet Clinic. And we're just going to use this as an example of a traditional monolithic enterprise Java application. So the idea with Pet Clinic is, as the name suggests, it's software that runs inside a vet's office that maintains a database of owners, a database of vets, and a database of pets. And you can schedule visits. So you can make an appointment for an owner to bring their pet in to be seen by a vet. And the domain model is pretty simple. There's owners, which represent people. They have one or more pets. And then pets can have one or more visits. And then you also have vets that have specialties. Architecturally, it has a standard Java EE architecture. So there's data access layer with repositories. There's a service layer. There's a web tier with controllers. And then there's some view code. So pretty standard enterprise Java application. But then let's imagine that a new requirement comes in. Want to have a system that has a proper modern web UI using AngularJS. That's the fashionable UI technology today. And it needs to have a more sophisticated system for maintaining the work schedules of vets. The old system, the model was a pet had a visit, but there was no tie-in with actual availability of vets or veterinarians. And so the idea here is that veterinarians would have these slots where they're available to see pets, and then the process of scheduling an appointment for a pet visit would be to assign a particular time slot with a particular vet. And one interesting aspect of this is that this is sort of a richer appointment model, but there's actually a one-to-one correspondence between one of these new appointments and a visit in the old legacy system. So one of the strategies I described earlier is how you should implement new functionality as a standalone service. So here's the proposed architecture that will implement this new appointment scheduling system. So there's an appointment service that's maintaining the vet schedule, and it's also keeping track of pet appointments. And it has an AngularJS front end. There's an anti-corruption layer that provides APIs in the form of repositories for accessing the legacy database. So those repositories basically define finder methods for looking up a vet, looking up a pet, looking up an owner. So, and there's a facade that's accessed over a remoting API that resides in the monolith that provides access to that data. So that's sort of a big idea. And then there's this, at the bottom, you can see there's an appointment created event handler. And the notion here is that this new system is implemented using event sourcing. When an appointment is created to associate a pet with a time slot belonging to a vet, that publishes an event, an appointment created event. And the event handler residing in the anti-corruption layer will then create the corresponding visit in the legacy database by making a create REST call to via the REST API and access the facade. And that will actually go and invoke the legacy domain logic for creating visits. So that's the big idea behind this new architecture. But there's an interesting kind of issue that has to be resolved. So the event handler that processes the appointment created events, invokes a facade that ultimately creates a visit in the legacy database. But event delivery is at least once, right? That's a standard attribute of messaging infrastructure. So that means that this event handler could, in theory, be invoked multiple times for the same event. And what we don't want to do is create multiple visits corresponding to the new appointment. But at the same time, we can't actually use like distributed transactions that span the service and the legacy database to handle this. And so we need some form of idempotency, so that, in other words, duplicate events don't cause duplicate visits to be created in the legacy system. In messaging terms, that's called an idempotent receiver pattern. So I think there's a few different strategies that you could use to ensure idempotent visit creation. Here's an approach that I've used. So when an appointment is created, an appointment created event is published, that gets processed by the appointment event handler that makes an HTTP request to the facade, saying, go create the corresponding visit. When the facade receives the HTTP request, it begins a transaction. So we've got a transaction that's just local to the legacy system and its database. At that point, it can insert a row into this appointment visit mapping table. So that's a table that's maintaining the mapping from appointment ID to visit ID, where the primary key is the appointment ID. So by doing this insert, it can actually detect duplicates, because if this post request had previously succeeded, there would now be a row in this table, and it would violate a primary key constraint and it would fail. Or it could actually return the same visit ID. So we can achieve idempotency by doing this check. Then, if that insert succeeds, the facade can then go and create the legacy visit in the visit table. And then it can execute an update to associate the appointment ID with the newly created visit. And then the visit ID gets returned back to the appointment event handler, which could actually tell the appointment that the visit had been created. So there's a strategy for reliably integrating a service with a monolithic application that can handle duplicate events in an idempotent fashion. So it's quite likely that you would need to use strategies like this when you're implementing your own anti-corruption layer. So as you can see, refactoring a monolith into a set of microservices is not straightforward. It's going to be a lot of work. There are lots of interesting issues with ensuring data integrity that you have to deal with inside the anti-corruption layer. Also, extracting modules out of a monolith is going to require some changes to the code. And so the whole process of taking your monolith, turning it into microservices, could very well be quite a lengthy project, taking some number of months. But if your monolith is getting in the way of your business, it's getting in the way of agile development and delivery, and it's just causing your whole development process to grind to a halt and move very, very slowly, then usually incurring the pain of refactoring is a very, very worthwhile investment, because living with a monolith is often quite an unbearable experience, and it has an impact on your business.